Hello everyone. So in the last video, we have talked about the insertion sort. That is how this particular sorting is working. We have seen using this particular piece of code, we have dry run each and every line and we have seen the working mechanism behind this insertion sort. Now in this video, we will be talking about the time complexity part for this sorting. And we'll be seeing that how the best case and worst case are different from each other in this case, because we have seen for selection sort both the things are same, but for insertion sort these two will not be similar. So let us have a quick look. Now what is the worst case scenario? Suppose we have an array and the array is like this one, say 7 6 5 3 2 1. So if you can check this array, what is the thing? That the array is reversely sorted. The array is reversely sorted, right? So if you haven't checked the earlier video where I talked about rigorously about insertion sort, I would recommend you to go and check that first and come back for better understanding purpose. Now, what we were doing exactly here, we were kind of setting key is equals to array of step. Step was starting from 1. So it is 0, 1, 2, 3, 4, 5. So the key was at array of step. So key was here. So key was nothing but key was equals to 6. And then j equals to step minus 1. So what is the value? J equals to 0. Now we are checking while j is greater equals to 0 and then key is array of j. J is greater equals to 0 satisfied and key means 6. So 6 is less equals to array of j, that is array of j is 0, that is 7. So 6 was less than 7 and j is equal to 0. So both are satisfying. So in that case it will go inside. What it will do? It will make the array look like that both will be array of j plus 1, that is array of 1 would be 7. So it will be 7 7 5 3 2 1 and then here the j plus 1 was getting replaced by key. So after this step, what was happening? The 6 was coming to its correct position because we are seeing only the first two elements, only these two elements, and the 6 is not its correct position. So 6 was coming before 7. 6 was coming before 7, right? I have talked about this thing again, I mean rigorously in the previous video, so you can watch that. So now after this iteration, how it will look like? It will look like 6 7 5 3 2 1. So next time what will you pick? The step will be plus plus. So step will be 2. Step is equals to 2. Now key equals to array of step. So that is array of 2. 0, 1, 2, 3, 4, 5. So this will be picked. So key is equals to 5. Key is equals to 5. Now j equals to step minus 1. What is step 2? So j is because j's value becomes 1. So j greater than 0 satisfied. Key greater than array of j. Key less than array of j. What is key? 5. 5. And what is array of j? Array of 1, that is 7 only, right? So what we are doing exactly, what we are doing in insertion sort, we are picking one element and we are comparing with the left of elements, the elements which are at the left. So if you pick 5, if you compare with 7, 5 is smaller than 7, so 5 needs a shift. If you compare with 6, 5 is smaller than 6 as well, so it needs both the shift. Now if you compare 3, after this iteration, how it will look like? It will look like 5, 6, 7, 3, 2, 1. So now if you pick 3, because the key value will be 3 now, 3, it will be compared with 7, 6, 5 and 3 will be jumping 1, 2, 3, right, and 3 will be coming here. Again after that 2 is smaller than everyone, so it will be 1, 2, 3, 4 and it will be here. Then again 1, it will be comparing with each and every element, right. So for the first time when the array was like that, the 6 was compared with 7. So only one comparison was needed, and for that this was while loop was satisfying because by default this external for loop will run from step 1 to step size minus 1, right? It will be do as it is. The main game is in this while loop. If you see for this array, this while loop for each value, that for 6, this while loop, this condition will be satisfied as well as this condition will be satisfied whenever 6 will be checked with 7. So this while loop will be executing for one time. Now for the next step iteration, whenever the value will be 5, this 6, the first j will be 2 and then key or something like that, this key is less than array of j, that is 5 is less than 7, it will be satisfied. Then it will be checked for 5 is less than 6, again satisfied. So this while loop will run for 2 times in the next step iteration. Next step will become 3, and like it will be here, it will be here. So 3 will be checked with this one, and this one. And this while loop, this condition will be satisfied every time, right? That is 3 is less than 7 satisfied, 3 is less than 6 is satisfied, 3 is less than 5 is also satisfied. So this particular while loop will run for 3 times. And so on. If you want to find the pattern, if there is the smallest element existing at the very last, it will be compared with all the n-1 elements. So this particular while loop at end will run till n-1, right? So what is the time complexity? That is n-1 into n-1 plus 1 by 2. That is n into n-1 by 2. That is nothing but big O of n square. So this is the worst case. This is the worst case. Right? Now if you want to see, suppose the array is sorted. Suppose the array is sorted. 1, 2, 3, 4, 5, 6. Suppose this is the array. 0, 1, 2, 3, 4, 5. So how it will work? It will pick 2. The 2 will be key first. Right? And it will be compared with 1. So this condition will check whether 2 is less than 1. So this will not be satisfied, right? Then it will be 3. So it will be checking whether 3 is less than 2. Because if 3 is not less than 2, it is not supposed to check with 1. Because this particular portion is sorted, right? So if 3 is less than 2, then only you can check with 1. Because 3 is not less than 2, so by default 3 will not be less than 1. Because this particular portion is sorted, right? So now 3 is less than 2. We are checking with this one. Right? So it will not be satisfied. Then we are checking 4 less than 3. So it will not be satisfied again this condition. Then 5 is less than 4, not satisfied. 6 is less than 4, not satisfied. So it will not go inside this while loop at least one time if it is sorted. It will be just be checking this particular part. It will just be checking this particular part. But it will not go inside this while loop ever again because it is already in sorted manner. So in that case, it will only depend on this particular value. So what is that? It would be n-1. What is t of n? Is equals to n-1. Right? Because it is not going inside this while loop once again. Nowhere it is going inside this particular loop. Not even a single time. Because this condition will never be satisfied if the array is already sorted. So in that case, what is the time complexity? T of n is equals to n-1. So in that case, it would be order of n. So this is the best case time complexity. And for average case, you need to, there is some random array, just like we were discussing in the previous video where you have talked about this thing, dry run and all these things. We have taken a random array. So there also we need at least a lot of comparisons very close to n square. So the average case would be also order of n square, any random array, for any random array. But if the array is reversely sorted, that is the absolute worst case in case of this insertion sort. And if the array is already sorted in a perfect manner, that is the best case for insertion sort. So for best case, the time complexity is order of n. For worst case, the time complexity is order of n square. So that's all about the time complexity for insertion sort. And if you can see, for best case, insertion sort performs better than selection sort, right? Or bubble sort. So far what we have learned, right? So that's why it is like quite helpful if your array is nearly sorted or almost sorted, you can go for insertion sort. It performs way better, right? So I hope whatever I have talked about in this video makes sense to you. Thank you for watching and stay tuned for the next video.